Okay, so welcome to this tutorial. As promised in the previous video, in this video, we are going to do some examples to illustrate everything we have learned previously. Okay, so in this tutorial, we will do 3 examples. Okay, so let me do the first example here. The, the question says the following. Use Gauss method, okay, to decide on the solution on the type. Okay, let me. On the type of solution of the following system. Of course, we are talking about linear system of equations. Okay, so our system is the following. We have x plus y, okay, plus w equals to -2 minus x plus y plus z plus w equals to 2. And 2x plus 4z minus w equals to 5, and 3x plus y plus 4z equals to 1. So this is our system of linear equations. Okay, and we are asked to decide on the type of the solution set. So previously we have seen the 3 types. So basically they are asking us to say whether this linear system of equation has no solution or has a unique solution or has infinitely many solutions. For the moment in this tutorial, we are not going to write the solution set of the system. We are just going to decide on the type of the solution. In future videos, we will see how to properly or how to write the solution set. Okay, but for now it's just to decide whether the system has no solution, has a unique solution, or it has infinitely many solutions. Okay, they are asking us to use Gauss's method. Okay, so let's through let's answer. Okay, so answer or solution. Okay, so what are we going to do? We are going to perform Gauss's method. And in the previous video, we have seen the theory about Gauss's method, and I have explained how we need to get the echelon form. So in this tutorial, I will go slowly. It may look tedious to someone who already knows how to perform Gauss's method, but this is our first time of performing Gauss's method, so I am going to take a lot of time to be able to explain it properly. Okay, then later on we will just fly through, Gauss's method, fly through it. But here, let me rewrite our linear system of equations. Okay, so x plus y plus w equals to minus 2. Okay. Yeah, okay, I want to do something, but that's fine. Then we have, I'm going to just recopy, okay, our system plus z plus w equals to 2, 2x plus 4z, I mean z, it depends on where you are coming from, okay? On the part of the word you are coming from where you can say z or z, okay? So 3x plus y plus 4z or 4z for some people equals to 1. Okay, so now we are going to perform Gauss's method. This is our first time. It's a beautiful method, okay? So basically, as I said, as you have seen in the theorem, we want to get this original system into echelon form. And we have seen what we mean by echelon form. So basically, we want to get something like this, okay? So that means we are going to eliminate, okay, those, some of the terms. So let's see. I'm going to start with row 1. So if you look at row 1, our leading variable in row 1 is x. We have seen what we mean by leading variable, okay? So our leading variable in row 1, okay, maybe let me change color. Our leading variable in row 1 is x. Now I'm going to use that term in x. Okay, I'm going to use it to eliminate, okay, the terms in x, in that same variable, in the rows below the first row. Okay, so what I'm going to have is okay, let me show. So how are we going to eliminate them? Let me remove what I have written. Okay, how do we eliminate? So first of all, okay, to be able to cancel minus x, what do we have to do? We just add x to minus x and it will become 0, okay? And in Gauss's theorem, we have seen a row combination. So what we are going to do is I am going to use row 1 plus row 2, okay? And replace the row 2 by the answer I will get. Let me do the operations somewhere here. Okay, so where can I do the operations? Yes, maybe let me do the operations somewhere here. Maybe it will make more sense. So let me write here operations. Operations. This is our first time to do Gauss's method, so I'm going to take time to explain it more into depth. Okay, so row 1, our row 1, okay, I'm going to use the Greek letter for row 1, is x. I'm going to recopy it here, row x plus y plus w equals to minus 2. Is that okay? Okay, so row 2 is minus x plus y plus z plus w equals to 2. So I'm going to add these two rows. Is that okay? So x minus x is 0. That's what I'm looking for because I want to eliminate the x in the second row. And here y plus y is 2y, 0 plus z is z, and W plus W is 2W equals to 0. Now, I'm going to change to replace row 2 by this row. So this is going to be my new row 2. Okay, maybe I can change color. This is going to be my new row 2. And Gauss's method says we can do row combination and we do not change the solution set of the system. Is that okay? So let me come back to here and I'm going to write what have we done here. Row 1 plus row 2, we say that it is equal to, we have x, we recopy the row 1, okay, equals to minus 2. But instead of row 2, I'm going to write my new row 2, which is this. Let me write it here, which is 2y plus z plus 2w equals to 0. Is that okay? Now, let me do, okay, so that's my first operation. Let me do another operation here. Okay, I'm think I'm not going to have enough space, but let me do it here. Now I want to use x in row 1 to eliminate the 2x in row 2. Okay, so how do I eliminate 2x? How do I cancel 2x? I have to multiply x by minus 2. Okay, so minus 2 times row 1 will give me what? It will give us minus 2x minus 2y minus 2w equals to 4. And I don't multiply row 2 by anything, okay? We are going to use row 1. We are going to do the operations or the multiplication or divisions on row 1 and add it to row 2, okay? So we are in row 3. Row 3, sorry. 2, I want to eliminate 2x, which is in row 3, okay? So row 3, I will recopy it 2x plus 4z minus w equals to 5. So I have minus 2x plus 2x is 0. That's actually the purpose of what we are doing. So I have minus 2y plus 4z minus 3w equals to 9. And I'm going to replace row 3 by this. Row 3. Okay, I don't have enough space, but I hope you can see. So row 3 is going to be replaced by minus 2y plus 4z minus 3w equals to 9. Okay, now let's do, so what have I done here? I have done minus 2 row 1 plus row 3. Is that okay? I don't have enough space here, otherwise I wanted to do something. Okay, so I'm going to recopy row 3 here and we will go to the other system, okay? So row 3 is 3x. I haven't changed row 3 yet, so let me recopy it as the way it is, okay, equals to 1. Why I don't want to perform everything here is because you see here what I have written in green is the Gaussian operations. And on one row, okay, when we have on one arrow, this arrow, okay, I just want to keep it clear, okay, where we can just do 2 Gaussian operations. So the first Gaussian operation is row 1 plus row 2. The second one is minus 2 row 1 plus row 3. Now the third one, I can't write the third one somewhere here, so I just want to be neat, okay? So let's do, what I'm going to do here is this. Okay, so I'm going to use this operation, this ecosystem, and do, I don't know yet, but so let me write it here. The thing is I don't have enough space here on this part, this screen, but I want to keep everything here. So let's do our third operation. Our third operation here is I want to use row 1, the x, to eliminate the 3x. So what I have to do is minus 3 times row 1, which is equal to minus 3x, minus 3y, minus 3w equals to 6. And row 4, I have to write it as the way it is. Row 4 is 3x plus y plus 4z equals to 1. So we have here minus 3x plus 3x is 0, and here you have minus 2y plus 4z minus 3w equals to 7. This is going to be our new row. Okay, I'm going to change row 3 by this. That's going to be our new row, row 3. So what have I done here is I said minus 3 row 1 plus row 4. That's the operation I have done. So far we haven't changed row 1, so let me rewrite it. Equals to minus 2. I hope I will have enough space on this part. Okay. And then, but we have changed row 2. So the change we have done previously to row 2 is 2y plus z plus 2w equals to 0. We have also changed row 3 minus 2y plus 4z minus 3w equals to 9. And we have just changed row 4, which is minus 2y plus 4z minus 3w equals to 7. Okay, so what we have done here, we have successfully used the leading variable in row 1 to eliminate the variables, the terms in that variable in the rows below row 1. So in row 2, in our new row 2, row 3, and row 4, we no longer have a term in x. Okay, so now let me go to the next screen because I don't have enough space here. So, okay, maybe the first step is to eliminate s. Okay, you want me to write it down here? Okay, maybe to make things clear. Step 1, here we are trying to eliminate x in row 2, row 3, and row 4. Is that okay? So this is the end of the first step. Okay, let me be sure that everything is correct. Okay. Okay, so let's go to the second step. So step 2 is to eliminate y in row 3 and row 4. Okay. No, I don't need to. Okay, so in this case, let me remove this because okay, just put it there. And here as well. I don't think we need it. Okay. So let me recopy the end of step 1. So this is step 2. Eliminate y in row 3 and row 4. Let me recopy the end of step 1. At the end we have x plus y plus w equals to minus 2. And we have here 2y plus z plus 2w equals to 0. We also have minus 2y plus 4z minus 3w equals to 9. And then we have minus 2y plus 4z minus 3w equals to 7. Okay, that's what we got after performing the first set of operations. Now, so we want to get the echelon form. In row 1, the leading variable is x. Now in row 2, the leading variable is y. Okay, so the leading variable is y. So we are going to use this term, the term in 2y, to eliminate the term also in y in the rows below row 2. Okay, so what I'm going to do is this. I know it's dangerous. Okay, so let me write operations here, and I'm going to change color, okay, of the operations just to make things clear. This is our first time, okay, of doing row operations. So let me change colors. Okay, so let me write operations here. Operations somewhere here. So yeah, I think I will have enough space, hopefully. So would you write operations here? So what are we going to do? I'm going to change row 3 and row 4. Okay, so I'm going to use row 2. Row 2, we have 2y. And I want to use 2y to eliminate minus 2y in row 3 and minus 2y in row 4. So how do I eliminate minus 2y in row 2? Row 3. So I just have to write row 2, sorry, which is 2y, because 2y plus minus 2y is going to be equals to 0. So I don't have to multiply row 2 by anything. So row 2, which is 2y plus z plus 2w equals to 0. And row 3, I just recopy it, minus 2y plus 4z minus 3w equals to 9. I hope so. I have 0 for 2y, for the y's, and then I have 5z minus w equals to 9. And I'm going to change row 3 by this new row, or this new equation. So this is going to be my row 3. Sorry. I came two down. So this is my row 3. Okay, so let's come to our equation. So what have I done? I have row 2 plus row 3. Okay, I'm keeping the color so that you can see the equations I have changed and those I have not changed. Okay, and you can see clearly what I have done to each equation. So x is unchanged. Okay, plus y plus w equals to minus 2. And in this second step, have I done anything to row 2? No. I have to recopy row 2. I actually used row 2 to do things to row 3 and row 4. So plus Z plus 2W equals to 0. Haven't done anything. However, I have changed row 3. What have I done to row 3? I add row 2 to row 3, and my new row 3 is 5Z minus W equals to 9. Okay, and so in here, this is our first set of operations. I'm going to do uh, another operation here for row 4. So still I want to use row 2, sorry, to eliminate the minus 2y. The same thing I have done previously. So row 2 is equal to 2y plus z plus 2w equals to 0. And row 4 is equal to minus 2y plus 4z minus 3w equals to 7. So minus 2 plus 2 plus 2y minus 2y is 0. I have here 5z minus w equals to 7. Okay, so this is going to be my new row 4. Row 4. So let me come here and copy it. So my row 4 is 5z minus w equals to 7. So what have I done to row 4? What Gaussian operations have I done to get row 4 is I did row 2 plus row 4. Is that okay? Now this is the end of step 2. Now step 3. So this is step 3. I want to do it on the same line, on the same row. Okay. Step 3 is I'm going to eliminate Z in row 4. Okay, I'm going to do it here. But let me change the colors of operations. Let me use this. So my here, okay, my new operations. I think I'm just going to have one operation here. Is so here, what I have to do is I'm going to use. Okay, so let's recall the first step is to use x in row 1 to eliminate x's in the rows below row 1. The second step is to use the y in row 2 to eliminate the y's in the rows below row 2. The third step now is to use the z in row 3 to eliminate the z in the rows below row 3. So basically to use z in row 3 to eliminate the z in row 4. So how do I cancel 5y is to multiply, the third row by minus 1. So minus row 3, this is 3. Oh, I hope you can see. Minus row 3, which is minus 5z plus w equals to minus 9, and row, I just recopy row 4, okay? So row 4 is 5z minus w equals to 7. So minus 5z plus 5z is 0, plus w minus w is 0, so we have 0 here, equals to, we have minus 9 plus 7, which is minus 2. Okay, so what have I done here? What Gaussian operation have I done is minus row 3 plus row 4 gives us what? I have changed only row 4, okay? So I haven't changed row 1, so let's recopy things. X plus y plus w equals to minus 2. In the second step, in the first step, okay, we have our 2y plus z plus 2w equals to 0. After the second step, you haven't done anything to row 2 anymore. Okay, after the first step, sorry. In the second step, when we eliminated y, we end up with the row 3, which is 5z minus w equals to 9. And in this third step, we have only done something to row 4. Okay, we haven't done anything to row 3. So we have 0 equals to minus 2. And here we have the echelon form. Okay, so as you can see, we start with the first, the original system, and now we have the echelon form. This is what we call the echelon form. Okay, so let's look at the first form. Okay, the original form, it looks something rectangular, and here in echelon form we have something that looks like stairs. So that is the echelon form. Is that okay? And in this echelon form, if each leading variable is to the right of the leading variable of the rows above it. So in the first row, the leading variable is x. In the second row, is the leading variable is y, and y is to the right of x, which is in row 1. And then in the third equation, okay, in the third row, the leading variable is z and is to the right of the leading variable in row 2. And then here, the third row, the fourth row, as you can see, is a contradiction. Okay, so this is a contradiction because we have 0 equals to minus 2, which is a contradiction. So we have a contradictory equation. So from the lecture, when we have in echelon form, we have a contradictory equation. What does it mean? It means that the equation or the system has no solution. Okay, so the system has no solution. The system has no solution. So this is the end of this first question. Okay, so this is how we recognize if a system has no solution. And I think I'm going to stop here. Otherwise the tutorial will be too long. In the second video is going to be also, we are going to continue the tutorial. In the tutorial actually about Gauss's method, we are going to do two questions, two systems of equations. Okay, the first one, as you can see in each question, okay, we will see the different types of solutions we have. So here we have a system that has no solution. That means in the second tutorial, in the next video, we may have in the next two videos, okay, we will have systems that have either a unique solutions or a unique solution or infinitely many solutions. Is that okay? So thank you for your participation in this video, for watching this video. It's our first time of doing Gauss's method, so I hope I explain it to you in depth. Okay, in the next video I am going to be a little bit faster, so make sure you understand everything here. Is that okay? So maybe a quick summary about Gauss's method. What have I done is I have the original system here, okay, and I want to arrive at echelon form. So basically I use the first row to eliminate the x in the other three rows. That's my first step. After that I use the y in the second row to eliminate the y in row 3 and row 4. Okay, so we have something like this. And then in the third step, I use the z in the third row to eliminate the z in fourth row. And then I have arrived at the echelon 4. Okay, and when we arrive at the echelon form, we have to ask ourselves, do we have a contradictory equation? If yes, then we have no solution. If we don't have a contradictory equation, that means we have either a unique solution or infinitely many solutions. And how do we know which one of the solution it is? We will see it in the next two videos. Is that okay? I hope I have explained it properly for you. So maybe just for consistency, here it's our new row 4. Okay, our new row 4. Is that okay? Thank you and see you in the next video.